Well, hi there, boys and girls. Today we're going to talk about geometric sequences in series. We've spent a few days on arithmetic, and now we're going to talk about what happens if a sequence doesn't have a common difference. It has something called a common ratio. And I'm going to talk to you about that. And so let's get out our pen and get after this. We've got a formula for an nth term of a geometric sequence, and that is the nth term is a sub 1, which we know is the first term, times r, and r is the common ratio, to the n minus 1 power. We're going to see how to find r. r you can find by dividing the next term by the previous term. We'll see an example of that. Now if you want to add up the first n terms, or a finite number of terms for a geometric sequence, it's given by this formula. The summation is the first term times 1 minus the common ratio to the nth, n is how many terms we have, divided by 1 minus r. r cannot be 1 here. And then if we are going to add up in an infinite geometric series, that means we're going to keep going on and on forever. The summation will be a sub 1 divided by 1 minus r, but that's going to be provided that our absolute value is less than 1. We'll see an example of that as well. So let's just get after this. First of all, let's look at this sequence and let's determine, is this arithmetic or is this geometric, or maybe is it neither? Alright, so to be arithmetic, we have to have a common difference. So let's see what's happening here. 5 to 7 is plus 2, 7 to 9 is plus 2. Well, this is arithmetic because we have a d, or a common difference. d equals 2. So this is an arithmetic sequence. Let's take a look at this one. Is this arithmetic or is this geometric? Got to know what you're dealing with so that you know what formulas to use. Alright, so 3 to 9 is plus 6. 9 to 27 is plus 18. 27 to 81, what is that, plus 54? Okay, so that is not arithmetic because I don't have a common difference. Now, to see if it's geometric, you take any term and divide it by the previous term. I've got a sub 1 is 3, a sub 2 is 9, a sub 3 is 27, and a sub 4 is 81. So all you do is you take any term and divide it by the one before it. So for example, I could take a sub 4 and divide it by a sub 3. 81 divided by 27, that gives me 3. Now let's try another one. What about a sub 3 divided by a sub 2? That would be 27 divided by 9. That's also 3. And of course, 9 divided by 3 is also 3. We have a common ratio. That ratio is 3, so this is a geometric. So a geometric series, we are multiplying each time. Times 3, times 3, times 3, common ratio. Alright, so let's find the first term in a geometric progression whose common ratio is 4 and whose sixth term is 1,280. So we have our formula for the nth term is the first term times the common ratio to the n minus 1 power. So we know the common ratio is 4 and we know the sixth term is 1,280. So we can put 1,280 as a sub 6. So let's plug this in. 1,280 equals, we want to find the first term, so I'm going to leave that as a sub 1. And we know the common ratio is 4, so I'm going to put a 4 here. And what goes up here is n. The sixth term is 1,280, so this is the sixth term, so we put a 6 up there. So we have 1,280 equals a sub 1 times 4 to the 5th power. Now I happen to know that 4 is 2 squared. And so 2 squared to the 5th power is the same thing as 2 to the 10th, because when we take a power to a power, we multiply. So 1,280 equals a sub 1 times 1,024. 2 to the 10th is 1,024. And we divide through by 1,024, and we simplify, we get the first term is 5/4. Now you would use a calculator on this, so don't worry about that simplification and be scared about that. So that's the answer to that one. That's the first term. Alright, let's do another one. The first term is -3 in a geometric progression, and the common ratio is -7. So I know the first term is -3, the common ratio is -2. Find the sum of the first 7 terms. So we have the sum of the first n terms, and we want to find that formula. Now our formula is S sub n equals a sub 1 times 1 minus r to the n, and that's all divided by 1 minus r. Again, we cannot have r equal to 1 here. That would be division by 0, and bad things would happen. So we want the sum of the first 7 terms, and we know the first term is negative 3. We know the common ratio is negative 2, and we're raising this to the 7th power, and we're going to divide this by 1 minus our common ratio, so 1 minus negative 2. So let's clean this up just a little bit. This is negative 3 times 1 minus. Now negative 2 to the 6th, I know, is 64. So negative 2 to the 7th is going to be negative 128. It's negative because we're raising it to an odd power. So I'm going to have negative 128 for negative 2 to the 7th. And I'm dividing this by 1 minus negative 2 is 3. I can probably cancel right here with these 3's. And so I've got negative 1 plus 128. So that works out to be negative 129. And it makes sense that this sum is negative because I'm starting with negative 2, and then I'm starting with negative 3, and I'm multiplying by negative 2 back and forth through the first 7 terms. So that is our answer. Okay, one last example. What if I'm going to infinity? This means this dot 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 means keep going, bro. And we have to first of all figure out that this is an infinite geometric series. And the only way this will do something called converge is if the r is less than 1. This will converge. That's a big, well, it's not really a big word, but it's a math word for has an answer. A finite answer anyway, only if the absolute value of r is less than 1. So how can I check that? Well, I can just take any two terms and divide them. Let's take a sub 2 and divide it by a sub 1. That's how you get r. That would be 1 divided by 6, and that's clearly less than 1. So this is going to converge. This has an answer. And our sum to infinity is the first term divided by 1 minus the common ratio, which would be 6 divided by 1 minus 1/6. And that would be 6 divided by 5/6, which we flip this over and multiply, we would get 36 over 5, which is 7 1/5 or 7.2. So this is what you guys will be doing in class tomorrow, and I will see you then.